Welcome and thank you for watching another video. Today we are going to indicate that when you want to estimate correlation using Excel, you should not rush to use the correl function in Excel. Instead, you have to create a scatter plot from the beginning. Let's dive deeper into Excel and check the following example. Here we have the annual total returns on two assets, asset A and asset B, from 1990 to 2020, and we want to estimate their correlation. So the tool provided by Excel to calculate correlation is the function correl that is consistent with the Pearson correlation coefficient that assumes that there is a linear relation between the two variables. So we start typing the equal sign, the word correl, we open bracket, and the first array includes the returns on asset A, and the second array includes the returns on asset B. And the correlation is found to be equal to 0.75. Another way to estimate the Pearson correlation coefficient is to use the data analysis tool pack that provides a correlation matrix. So from the menu bar, we check data, data analysis. From the scrolling list, we select correlation. As an input range, we select the annual total returns including their labels, and that's why we check the labels checkbox. And the output can be somewhere here. So the correlation coefficient is found to be exactly the same as before and equal to 0.75. We sense that this result is okay, that the returns on asset A and asset B are correlated and that there is a high correlation. However, this is not the optimal approach, as we are going to show using the scatter plot. So in order to create a scatter plot, we select the annual returns on asset A and asset B, and from the menu bar we check Insert and we select a scatter plot. We check the trend line, and from the More options we can see that if there is a linear relation between the returns on asset A and asset B, this relation involves an R-squared coefficient equal to 0.57. The square of the Pearson correlation coefficient is always equal to the R-squared coefficient. So the square of the correlation coefficient is found to be equal to 0.57 and exactly the same as the R-squared coefficient. So the greater the R-squared coefficient, the greater the correlation between the returns on the two assets. However, if we assume that the relation between the returns on asset A and asset B is not linear, let's check this. We are going to find that the relation is found to be much higher. For example, if we assume that there is a logarithmic relation, the R-squared coefficient is found to be 0.58. If we assume that a second-order polynomial model describes this relation, the R-squared coefficient is found to be higher than 60%. If we increase the order of the polynomial model, we find that the R-squared coefficient is 0.70 and significantly higher than the R-squared coefficient of the linear model. That's why we should not rush to use the correl function in Excel, and instead we have to create a scatter plot from the beginning. Thank you very much for watching.